Let's look at question number 3. And question number 3, we shall be looking at data handling. This is data handling. Staff at public schools are required to adhere to stipulated percentages of fractions relating to the total number of weekly periods based on their post levels. Table number 5 below shows the stipulated teaching time per post per school type. Right. You go through the table and you find out this is the staff levels and the, what is it called? Primary and the secondary type. Okay, there we go. Woodhill Senior Secondary School, SS, has a timetable with 40 periods per week. Shown below are the number of periods per week allocated to their staff members. The missing value D represents the number of periods taught by the deputy principal. Moloto Primary School, PS, has a timetable with 37 periods per week. Shown below are the number of periods per week allocated to their staff members. Okay. Determine the number of staff members at Woodhill SS. Now, remember, how will you tell? You can't add these values. This number represents one teacher. Why? They are saying the number of periods taught by, sorry, it's here. Yeah, number of periods per week allocated to their staff members. Allocated to their staff member. So this each number here represents a person. Okay, so we count them and we find out, let's say, this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 by 1, 2, 3. So it will be 10 by 3 minus 1 because here there's no 1 here. So it will be 29. 29. 29. Okay. Write down the model number. Write down the model number of periods per week for Moloto PS. Now, another thing that you need to take here note of, we are looking at the model number. This would still be the same as mod. Mod, we are looking at the number that appears most. Okay, we come here and just check. We have 10 appears once, 23 appears once, 25 appears once, 27 appears twice, 29 appears 4 times. 29 appears 4 times, 30, 1, 2, 3, 4, 5, 30 appears 5 times, 31 appears 3 times, 32 appears 3 times, 34 appears once. All right, now the model number becomes the one that appears most, and it's 30. 30 is the model number. The mod equals to 30. We come to the other question, calculate the missing value of D. How are we going to calculate the missing value of D? We shall look at it as they told us. It is the value D represents the number of periods taught by the deputy principal. Then we shall come up here. Deputy principal. Okay, deputy principal, where are we? Is here. But in which school? SS, this other side. Oh, okay, they share the same fraction. So of the 40 with 40 periods per week, of the 40, deputy principal will take what? We shall say it's 3 out of 5 times 40. And the answer here, I believe it becomes 6. Right, the answer becomes 24. Indeed, it's 24 because it's 26. All right, there we go. Then I stated that since the calculated mean Hood is 33. The median will be better reflection of the average number of periods taught by staff members. Justify in a statement with calculations. Justify calculating in a so mean is already 33 on average. This is what it means. So what about the median? So we need to look for the median. But median is half of the 29. Let's divide that. Because there are 29, 29 members that we're looking at. So we divide that by 2. So we find out that the median will be the 15th number. We shall come to the table, we count until we reach 15. Count, we come in, say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So here, 35. Then she says the median will be a better reflection of the average number. Yes, it's true. Because median is what? Median is the 35 better than the mean on average. Then another thing is that median is not affected by the outlier. An outlier is that number that's extreme. For example, here we have an outlier of 3. Because if D is 24, so these numbers are almost closer to each other. But look at the 3. This is an outlier. So median is not affected by the outlier. Okay. Determine as a fraction the probability of randomly selecting a staff member at Moloto PS who teaches 29 or more periods per week. Moloto, now we are coming here. 29 or more. 29 or more. Definitely, these are numbers in alphabet. Sorry, they are already arranged, smallest to biggest. So if you're looking for 29 and more, that means we have to remove these off. So we need to find out how many of these are C. 1, 2, 3, 4, 5, 6, 7. 7 by 4, you get 28. So there are 28. You get 28 out of the, this is the total number of teachers. Out of the 28, what's the probability that you get someone who takes, who has 29 periods and above or more? We are looking for a teacher who teaches 29 periods or more. So what we are going to do with of the 28, we're going to remove this 1, 2, 3, 4, 5. What do you remain with? So it's 23 out of 28. That's what they wanted us to do. A fraction as a fraction. So the answer here for 3.1.5, it's 23 out of 28. So 23 teachers teach. 23 teachers teach more than they teach more than 20, they have more than 29 periods. Okay. Let's look at question number 3.2. 3.2, still we are looking at data handling. Table 6A below shows the percentages achieved in term 1 by 10 selected learners of Woodhill SS for task 1 and task 2 in mathematical literacy. So students, learners are given alphabets here. We have A, B, C, D, E, F, G, H, I, J. These are the 10 learners that we're looking at. On our next chart, sorry, on the answer sheet provided, the performance of learner A to J for both tasks are plotted on the graph. Use table A, 6A, and the graph on the answer sheet to answer the questions that follow. Name the type of graph that is on the answer sheet. Name the type of graph that is on the answer sheet. Oh, this is the answer sheet they are looking at. Oh, this is what we are looking at, 3.2. So we are answering question number 3.2.1, part A. What type of graph? The answer sheet, the graph that looks like this. The dots are everywhere. It's called a scatter plot. It's called a scatter. It's a scatter plot. All right, calculate the range of the percentage achieved in term for task 2. But remember here, you need to give us a formula for range, which is the maximum minus the minimum. Highest value minus the lowest value, the biggest minus the smallest. So we shall go to task 2 and identify those. Here we see the highest is 81. So this is the highest. Task 2, this is what we are looking at. And the lowest is 15. So we shall come down there and you shall say 81 minus 15. And the answer becomes 81 minus 15. The range is 66. The range is 66. Identify the learner whose marks for both tasks can be classified as an outlier. Remember, we told you an outlier is that number that is weird from others. For example, let's check here. We have 71, 79, 80, 68, 63, 53, 72, 22. You see that? Then we go to 76 and 84. 22 is far away. It's not even near any of these other numbers. So 22 is an outlier. We come down there, this definitely you've seen 15. 15 is an outlier. You see that? Because the value is weird. It's far away from the others. So they're telling us, identify the learner whose marks are for both tasks can be classified as an outlier. Give a reason for your answer. So we are saying learner H. Why? Because these values are extreme. Extreme. They are they're extremely low, or they're extremely lower than the others. Extremely low, lower than the others. An outlier. School subject policy states that the difference between the mean of two, the mean of the two tasks should be below 15%. The mean should be below 15%. So the mean for task 1 is calculated as 66.7%. A teacher claimed that the difference in the mean mark for both tasks falls within the school's subject policy. Remember, the school subject policy says it should be below 15%. Should be below 15%. Verify showing all calculations where this teacher's is stated. So we already have for task 1. So what are we looking for? We need to look for mean for task 2, whereby we shall add all the numbers. We are going to add all these numbers on top. We need to add all these numbers here. We add all these numbers of task 2, these numbers here. So we are going to add them, which is 53 plus 69 plus 53 plus 49 plus 50 plus 47 plus 61 plus 15 plus 47 plus 81. So we end up having 500. When you add all these numbers, we end up having 525. 525, but remember we've added for 10 students. So you divide by 10, and we end up having 52. Remember, they are percentages. So what do we do now? Next, we look for the difference between. So the difference between it will be 66,7 minus 52,5. 66,7 minus 52,5. Indeed, you get 14,2%. So the claim is valid. We are not supposed to, here you are supposed to only get the mean for task 2 because task 1, the mean is already given to you. The mean is already given to you. So you have to look for the, okay. We look at the other question here, which is 3.2.3. The 3.2.3, the achievements of the two other selected learners, K and L, were added to table A to create table B. All right, here we go. These are the two learners that have been added. So they are telling you, use an answer sheet provided where performance of learner A to J for both tasks are plotted to plot the results of, now we're going to plot the results of learner K and learner L for both tasks. Clearly label the points K and L. Clearly label the points K and L. Let's go to the answer sheet and we do that. Now, K, task 1. Now, when you take a look at, the next chart, this is how it looks like, the graph. Then we have task. We have task 1 down here. That means the value for task 2 there this side. So you plot task 1 against task 2. We go to the table. We start with the K. These ones are already plotted. These other ones we already what? These ones are already plotted. There's nothing much. So we're only concentrating on these two. So it's 68 versus 40. 68 below because it's in task 1 and 40 is on this other side. So first and foremost, before you calculate task. So here we go. 68, we need 68, but count the lines in between, the lines from here to there. So we start with this one here. We have 1, 2, 3, 4, and 5. But what is the difference between these two? This is 20. So we ask yourself, each line represent, what does each line represent? So we shall divide 20 by the 5. 5 comes with the number of lines that we have there. So each line represents 4. So we want 68. That means we shall have 64 and 68. So the 68 is here, right? This is 68. Now, 68 means what? 68 is already seen. What about the 40? 40 is on task 2. So we shall also come here also. Oh, this is straightforward. So this is 40 already, it's there. When does it meet? So we shall follow this line and we plot here. So this is our first what? Scatter plot. They told us to clearly name it. So this is our K. This is K. Okay, we continue. Now, what about L? L, it's 88 versus 64. It's nice. So remember, each line we said it represents 4. So 88, still 88 is this one here. Because 84, 88, then 84, 88, then 92, 96, 100. Okay, yeah, there. So that's 88 88 is you can say it's from this dark line twice. So 88 from this dark line going this side versus 64. All right, 64, it has to be in between. 64 has to be in between 60 and 40. Do the same. Calculate how many lines are there. So we have 1, 2, 3, 4, 5. Oh, there are 5. But the difference here is what? 10. 70 minus 60 is 10. So when we divide by the 5, we get 2. So each line represents 2. We are not interested in 62. We're interested in 68. So how many lines shall we take? We have 62, 64, 66, 68. So this is a line. This line, when does it meet this one here? This is the point. So we shall come back and label it as L. So these are the 2 points of the learners that we are supposed to plot. Okay, we go back to question number 3.2.2. And this marks the end of question number 3.